Welcome to this episode of Robert's Creative Chronicles. So today I'll be teaching you about super mesh analysis. So here's the circuit. This circuit has three meshes, mesh 1, mesh 2 and mesh 3. Now a super mesh is a mesh that is constituted when two adjacent meshes share a common current source. Now mesh 1 and mesh 2 is sharing this current source between them. So this has formed a super mesh. So mesh 1 and mesh 2 have formed a super mesh. Now, super mesh analysis is similar to normal mesh analysis, but in this one, you also apply KVL to the super mesh. So now the solution to this, the first step, you have to identify the position of the current source. The current source is here, here, here. The current source is common to the two meshes, 1 and 2, yes. So super mesh is nothing but the combination of meshes 1 and 2. As I explained, the super mesh is now formed by mesh 1 and 2 combined. So this is the super mesh. Now the second step is to apply KVL to the super mesh and to other meshes. Applying KVL to this super mesh, that is combination of meshes 1 and 2, we get. So when you're applying KVL to this super mesh, you have to assume that this branch is removed. The branch that is inside containing this current source and this resistance 2 R2 has been removed. Then you apply the KVL around this outer circuit. That's how you apply KVL to a super mesh. You assume that this branch is removed. So when we apply it around here, we are going in clockwise direction. This voltage will be positive, so it's V positive. Then we are moving here. Since we are moving in the same direction of the current, and normally current moves from higher to lower potential, so here will be negative R1 I1, negative R1 I1. So here, it's I1 that is flowing through this. So here is I2 that is flowing through this, but this resistor is between two currents. So, and when current, this one is coming down and this one is going up. So these two currents are coming against each other. But since we are doing this in relation to this super mesh, the one we are going to take first is I2. So we'll take the difference I2 minus I3. If we are applying KVL to mesh 3, we are going to take I3 minus I2. But since we are applying KVL to this super mesh, we have to take it first. So it will be R3, negative R3, I2 minus I3. Negative R3, I2 minus R3 equals to 0. Then we rearrange it. If you take this V to the other side, it becomes negative. Then we multiply negative across to become all positive. So that's how we got this. Now, applying KVL to mesh 3, we get, when we apply KVL to this third mesh, we will get what? You see R3, I3 minus I2. So we will get R3 is negative since we are moving in the same direction as the current, which moves from higher to lower potential. So it's negative R3, I3 minus I2. Negative R3, I3, negative R3, I3 minus I2. Since we are doing this KVL with respect to mesh 3, that's why we are taking I3 first, then minus I2. Because this current is coming here and this one is coming down. They are moving against each other. So we have to find the equivalent, which is the difference between them. Then here also is what? Negative R4 times I3. So it's negative R4 times I3. But then we multiply through by negative. Since this one is negative and this one is negative, you multiply everything, you get all positive. So that's how we arrive at this equation. But ideally, it's negative, negative. Or you can multiply it, you can manipulate it to get positive, positive. Since they are both negative, you multiply minus 2. So those are the two equations. Then step 3, make the relation between mesh currents with current source to get the third equation. Third equation is nothing but the relation between I1 and I2, which is this. So to get the relation between the mesh currents, we have to apply KCL, that is Kirchhoff's current law. So Kirchhoff's current law states that the total or the algebraic sum of currents entering a junction is equal to the algebraic sum of currents leaving that junction. So this is the junction we'll be considering. That is why I mark it here with this red dot. A current is entering this junction. I2 also is entering this junction. Then I1 here is leaving this junction. So there are two currents entering this junction. So I2 plus I will be equal to I1, which is leaving the junction. That's what KCL states. So in here, see it. So I plus I2 will be equal to I1. The algebraic sum of I and I2 will be equal to I1, since I1 is leaving the junction and these two, I and I2, are entering it. So the sum of these two will be equal to this. So if you rearrange it, I plus I2 is equal to I1. So if you take this to the other side, you get I plus I2 equals to I1. But it has been rearranged to this. That's why it's written here like this. Or this is how you get this equation. Then the last step, solve the above equations to get the mesh currents. So you solve them, the simultaneous equations, using any method you want, whether substitution, either elimination, Cramer's rule, anyone, you can solve it to get the mesh currents. So you can use any method you want to find the mesh currents. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel and hit the notification bell to get notified as soon as I drop a new video. Thanks.